Hello everyone, in this video we're going to look at elastic potential energy. What I'd like you to do is to make the notes that are on the PowerPoint slide here now into your books please. And that's that the energy stored in a stretched or compressed object is known as the elastic potential energy. And then it gives you the equation for elastic potential energy, which is given on the equation sheet in your exams. And that is the elastic potential energy is equal to 0.5 multiplied by spring constant multiplied by the extension squared. If we look at those individual symbols, you get E is equal to half KE squared. So you might want to pause the video now and make these notes into your book. Once you finish making the notes, we're ready to move on. It might be a good idea to just go through and also highlight what these different values are measured in. So you can pause the video now to make the notes. Okay, so we're going to look at a worked example now, and the worked example says if a spring has a spring constant of 15 newtons per metre, and is extended by 0.5 metres, it wants to calculate the elastic potential energy stored in the spring. So to do this, again, you want to work through this in your books, and you want to make a note of it as we go along. The first thing you do is you're going to highlight what you've got in the question. So I've got 15 newton metres, so that's my spring constant. And I've also got 0.5 metres, which is my extension. And now what I'm going to do is I'm just going to put those numbers into the equation. So I would write that my EE is equal to 0.5 multiplied by 15 multiplied by 0.5. Now I must remember to square my extension, so I'm just going to put that in brackets, put a squared term around there. And now what you want to do, you just want to reach for your calculator, you put those numbers in. So 0.5 times 15 times, open brackets, 0.5 squared, and you get an answer at the end. I recommend you put that into your own calculator to check you get the same answer. That comes out to be 1.875. Now I want to round that up. I've got two significant figures in the question, so I want to call that 1.9. And then I must remember my units as well. And energy, remember, is measured in joules. Okay, so I've got two questions on the screen now. I'd like you to have a go at these two. So work through them. Remember to go through the process of highlighting the numbers first and then putting the numbers into your equation. So please pause the video now and attempt both of these questions. On the next slide, I'm just going to run through the answers for you briefly. Okay, so I'm just going to go through the answers with you here. So just a reminder that the first thing you should do is highlight the spring constants. They're both measured in newtons per metre. And you also want the extensions, 2 metres there, and 0.45 metres there. So hopefully you managed to go through and highlight that. That's just a case of putting those into your calculator. Okay, what we should have got for the first one is we should have had an equation. So I'm going to put number 1 up here, just to go through the room. So you should have got that E was equal to 0.5 multiplied by 2.5 multiplied by 2 squared. If you put that into your calculator, you come up with an answer that E is equal to 5.0 joules. Moving down to question 2, I'm just going to do that one here. You would again use the equation E is equal to, you've got the 0.5 multiplied by 7.6 multiplied by 0.45 squared. Placing that into your calculator and to get an answer now. So by putting that into your calculator, you should come out with an answer of 0.7695. So you want to round out two significant figures, because that's what we've got in the question. So that will be 0.77 joules. That's the answer to question 2. Remember to be writing these into your book as we go along. So we've got another work example here. It's going to involve us rearranging the equations slightly. It's always useful to have a go at these. So again, please just work through and record this information as you go along. So I'm going to go through and look at here. So I've got 6 centimetres. So that's my extension. And then I've got 0.5 joules, which is my potential energy. Okay, I've also got an issue here that I've got centimetres. I need to think about how to convert that into metres, because that's what I use my extension. So I'm going to start by converting this. So 6 centimetres, so that's my extension. I'm going to say that that is equal to 6/100. That gives me 0.06 meters. And then I'm going to go through and put my numbers in here. So I get 0.5 is equal to 0.5 times, I'm going to use a symbol for spring constant, which is K, multiplied by my extension, which we've got is 0.06 squared. So now what I need to do is I need to rearrange this. So to do that, I'm just going to put it into a slightly nicer form. 0.5 is equal to 0.5 times 0.06 squared times K. So you can see here I want K by itself. I've got times here, so I'm going to take this through as a divide. So I'd end up with 0.5 over 0.5 times 0.06 squared equals K. And if I put those numbers into a calculator, I'll find that K is equal to, I get 277.7. So I can leave that as being equal to 278 newtons per meter. Okay, if you move on to the next slide, you'll be ready to work through some of your own questions. So these are the two questions here. I'd like you to pause the video now and have a go at these two questions. Remember that you're rearranging the equation to find, in this case, spring constant. If you need any help, you can always move forward on to the next slide where I go through them with you. So remember again, the first thing is to highlight what you know in the question. So I've got 60 centimetres here, which is my extension. I've got 10 centimetres there, question 2. I've also got that my energy, measured in joules, is the elastic potential energy. Now all I need to do is put that information into the question and make sure I put the numbers in the correct places. So for the first one, I'm going to go up and just change this one here, that's 60 centimetres, which should be 60 over 100 to get 0.6 metres. Putting that into the equation then, I would end up with my 0.14 for energy equals 0.5 multiplied by K multiplied by 0.6 squared. I need to rearrange to find K, and I would have that K would be equal to 0.14 over 0.5 times 0.6 squared. If I put that into my calculator, I'll end up with an answer of 0.77 recurring here. So 0.78 newtons per meter. With question 2, I'm going to do that down here. So I'm going to get my E equals 0.5 KE squared. I'm just going to put the numbers in again. So I get 0.25 equals 0.5 times K times my E squared, 10, which is going to be 0.1, isn't it? 0.1 meters. Because 10 divided by 100 gives you 0.1. That needs to be squared. So if I was to rearrange that, I'd end up with the equation that K was equal to 0.25 over 0.5 times 0.1 squared, which will give me an answer of 50 Newton meters. Okay, so yeah, hopefully you managed to get those questions correct. If you made any mistakes, please improve your work as we go through. I'm going to move on to the final variation of this equation now. Okay, we're now going to move on to the final work example, and this is probably the more difficult one. So again, we go through the same process where we highlight the key information that's in the question. So it says spring stores 0.25 joules of energy, so that's the elastic potential energy. And it also says the spring constant is 4.8 Newton meters. So now all we need to do is we need to put that information in here. So we get that 0.25 is equal to 0.5 multiplied by 4.8 times, I'm going to call extension E squared. So now we're going to get a rearrangement here. So we get 0.25 over 0.5 times 4.8 is equal to E squared. So then we have to square root the 0.25 over 0.5 times 4.8 to get E. And if we put it onto a calculator, you'll find that E is equal to 0.32, rounded to two significant figures, and that should be meters. Okay, so hopefully you've followed that through. The key thing here is the squared term means we need to introduce a square root. And what I'd like to do next is move on to the next slide and have a go at the questions. So these are the questions. Use the same method that we've done in the work example before. I'd like to answer these in your book, and then I'm going to go through the answers with you in just a moment. Okay, so I just run through these questions with you again. So just to run over these ones so far. If we go through and highlight the energies first, in question 1 you got 1.2 joules of energy. And in question 2 you got 5,000 joules of energy. We've also been given our spring constants. So 440 Newton meters in the first question and 2,000 Newton meters in the second. And then it's just a process of putting those numbers into the equation as we've done before. So for the first one, we'd end up, I'll do it up here, if you can squeeze it in, 1.2 would equal 0.5 times 440 times E squared. Rearranging that, you should get that E is equal to 1.2 over 0.5 times 440 square rooted. And if you put that into your calculator, you should get the answer. And that comes out to be 0.07 meters. I'm just going to highlight that so it makes it easier for you to see. 0.07 meters there. Question 2, I think I've got a bit more room for this one. So if we go over here with question 2, we're going to put the numbers in again, so we'd end up with 5,000 this time is equal to 0.5 times 2,000 times E squared. And then rearranging that process, we'd end up with 5,000. We have to take this bit down. 0.5 times 2,000 equals E, and to get rid of the square, we square root it. And again, you can put that into a calculator to get the answer. So once you put that into a calculator, you get the answer of 2.2 meters, and that's the final answer that you needed there. So thank you for watching this through. You can now move on to the work that I've set you in the show folder in class. Thank you. Goodbye.